Alright folks, Buzz here. Today we're looking up at those incredible machines helicopters. They're marvels of engineering, but things can, and sometimes do, go catastrophically wrong. We're talking about mechanical failures that can mean the difference between a safe landing and a front-page tragedy. When something critical gives out on a helicopter, the options become severely limited, and the consequences can be dire. It's a sobering thought, but one we need to face if we're going to appreciate the skill of the pilots and the diligence of the mechanics who keep these birds flying. That's why we're diving into this today. Not to scare anyone, but to shed some light on what can go wrong. Understanding these failures isn't just for engineers or pilots, so buckle up because we're about to get into the nitty-gritty. So, let's start at the top, literally. The rotor system is the heart and soul of a helicopter. When this system decides to have a bad day, there aren't many worse days you can have in aviation. One of the real insidious enemies here is something called fatigue. Imagine bending a paperclip back and forth over and over. Eventually it snaps, right? Metal in a rotor system experiences something similar, just on a much grander scale. Over thousands of hours, tiny, almost invisible cracks can start to form. These are fatigue cracks, and they're like a ticking time bomb hidden deep within the metal. Mechanics and engineers use all sorts of fancy techniques to try and find these gremlins before they cause trouble. But even with all that, sometimes these cracks can be incredibly difficult to detect. Then you've got blade defects. Even a small nick or dent, if it's in the wrong place on a rotor blade spinning at hundreds of RPM, can become a stress point. When a rotor blade fails, the results are almost instantaneous and universally horrific. The helicopter will immediately lose lift, often in an asymmetric way, meaning it starts to tumble or spin uncontrollably. The forces involved are immense. If that energy is suddenly released in an uncontrolled manner, the airframe can be torn apart in seconds. Pilots train for a lot of emergencies, but a catastrophic main rotor failure at altitude gives them virtually no options. This is why the design, manufacture, and maintenance of rotor systems are subjected to the most stringent standards in aviation. Every bolt, every bearing, every square inch of those blades is critical. The main rotor system demands absolute perfection, flight after flight. Alright, if the rotor system is the heart, then the engine or engines are the muscle of a helicopter. These power plants are what spin those life-giving rotors. An engine failure means you've lost your primary means of staying airborne. One of the common culprits behind an engine saying no more is the fuel system. It's a complex network of pumps, filters, lines, and injectors, all working to deliver a precise amount of clean fuel. If you get a blockage, the engine can starve. The engine sputters, coughs, and then silence. Then there are the internal workings of the engine itself. We're talking about parts moving at incredible speeds, under high temperatures and pressures. If a bearing fails, if a turbine blade decides to liberate itself, or if the lubrication system isn't doing its job, things can go south in a hurry. The impact of an engine failure is immediate and undeniable, a sudden loss of power. Now, helicopter pilots are a special breed. They train extensively for this exact scenario. It's called an auto-rotation. Essentially, they use the airflow coming up through the now unpowered rotors to keep them spinning, allowing for a controlled, albeit unpowered, descent. It's an amazing feat of airmanship, but it requires altitude, skill, and a suitable place to land. However, not all engine failures are created equal. Sometimes an engine might start to lose power gradually, giving the pilot a bit more time to react. Other times, especially in twin-engine helicopters, if one engine fails, the other is designed to pick up the slack. But imagine an engine failure at a low altitude, say during takeoff or landing. The window for a successful auto-rotation shrinks dramatically. The skill of the pilot is tested to its absolute limit in these moments. The roar of that engine is the sound of safety, the sound of power. Now, having a perfectly good rotor system and a roaring engine doesn't mean a thing if you can't tell the helicopter what to do. That's where the control system comes in. These are the linkages, the rods, the cables, and critically, the hydraulic systems that translate the pilot's subtle movements into precise changes in the rotor blade's pitch and angle. When these controls go bad, the pilot can quickly become a passenger. Many helicopters use hydraulic systems to assist the pilot. These hydraulic systems use pressurized fluid to move actuators that in turn move the flight controls. But if that hydraulic pressure disappears, things get dicey. A common cause of hydraulic failure is a leak. As the fluid level drops, so does the pressure. The controls will start to feel stiff, sluggish, and then, potentially, lock up or become incredibly difficult to move. Sometimes it's not a leak but a pump failure. Most helicopters have redundant hydraulic systems, meaning if one fails, another can take over. But if you lose all hydraulic power, the pilot might have to revert to manual control. Beyond hydraulics, you've got the mechanical linkages themselves. These components can suffer from wear, corrosion, or even incorrect maintenance. A jammed linkage, a disconnected rod, or a frayed control cable can lead to a partial or complete loss of control. The scary part about control system failures is how quickly they can escalate a situation. In the dynamic environment of helicopter flight, the ability to make instantaneous, precise control inputs is absolutely critical. Losing that ability, even for a few seconds, can be catastrophic. Maintenance here is key. Alright, we've talked about the main rotor doing the heavy lifting, but there's another critical spinning component on most helicopters that often gets overlooked until it's too late. The tail rotor. That smaller set of blades at the back isn't just for decoration, it's absolutely vital for directional control and for counteracting the torque produced by the main rotor. When the tail rotor decides to take an unscheduled vacation, the helicopter can enter a violent, uncontrolled spin. This loss of directional stability is incredibly dangerous, especially at low airspeeds or during a hover. The pilot suddenly finds the aircraft rotating on its vertical axis and their ability to steer is gone. So, what can go wrong with this crucial component? Just like the main rotor, the tail rotor has blades that can suffer from fatigue or damage. It also has a gearbox that needs to spin at a very specific RPM. If that gearbox fails, the tail rotor will stop turning. Then there's the drive system. The tail rotor is usually driven by a long drive shaft running from the main transmission back to the tail. If one of these components fails, the connection is broken, and the tail rotor loses power. The consequences of a tail rotor failure depend a lot on the phase of flight. In forward flight, the vertical fin or stabilizer on the helicopter can provide some aerodynamic stability. However, if a tail rotor fails during a hover or at low speed, the situation is far more critical. Now, we've talked about the spinning bits and the power bits, but what about the very skeleton of the helicopter? The airframe. This is the structure that everything else bolts onto. The cabin, the engine, the transmission, the rotor mast, the tail boom. It's the framework that has to withstand all the aerodynamic loads, the vibrations, the landings. If this underlying structure is compromised, it's like having a house with a crumbling foundation. Sooner or later, everything is coming down. Airframe failure isn't always as dramatic or sudden as a rotor or engine failure, but it can be just as deadly. We're talking about structural problems, stress fractures developing in critical load-bearing members, corrosion eating away at the metal, or damage from a previous hard landing or incident that wasn't properly detected or repaired. These issues can weaken the airframe to the point where it can no longer handle the stresses of flight. Think about the forces a helicopter airframe endures. The lift from the main rotor is pulling up on the mast, which is connected to the transmission, which is mounted to the airframe. The weight of the engine, fuel, passengers, and cargo is all being supported by this structure. During maneuvers, these loads can multiply. Every vibration from the engine and rotors is also being absorbed and transmitted through the airframe. Stress fractures can develop over time, much like fatigue cracks in rotor components. Corrosion is another silent enemy, especially for helicopters operating in marine environments or humid climates. Sometimes an airframe failure can be the result of a specific event. A very hard landing might overstress the landing gear and the surrounding structure. If that damage isn't fully assessed and repaired, it can create a weak point that might fail later under normal flight loads. Detecting airframe issues requires incredibly thorough inspections. Mechanics spend hours poring over the structure looking for cracks, loose rivets, signs of corrosion, or any deformation. Missing a small crack in a critical longeron or bulkhead could have devastating consequences down the line. Now, we've talked about the spinning bits and the power bits, but what about the very skeleton of the helicopter? The airframe. This is the structure that everything else bolts onto. The cabin, the engine, the transmission, the rotor mast, the tail boom. It's the framework that has to withstand all the aerodynamic loads, the vibrations, the landings. If this underlying structure is compromised, it's like having a house with a crumbling foundation. Sooner or later, everything is coming down. Airframe failure isn't always as dramatic or sudden as a rotor or engine failure, but it can be just as deadly. We're talking about structural problems, stress fractures developing in critical load-bearing members, corrosion eating away at the metal, or damage from a previous hard landing or incident that wasn't properly detected or repaired. These issues can weaken the airframe to the point where it can no longer handle the stresses of flight. Think about the forces a helicopter airframe endures. The lift from the main rotor is pulling up on the mast, which is connected to the transmission, which is mounted to the airframe. The weight of the engine, fuel, passengers, and cargo is all being supported by this structure. During maneuvers, these loads can multiply. Every vibration from the engine and rotors is also being absorbed and transmitted through the airframe. Stress fractures can develop over time, much like fatigue cracks in rotor components. Corrosion is another silent enemy, especially for helicopters operating in marine environments or humid climates. Sometimes an airframe failure can be the result of a specific event. A very hard landing might overstress the landing gear and the surrounding structure. If that damage isn't fully assessed and repaired, it can create a weak point that might fail later under normal flight loads. Detecting airframe issues requires incredibly thorough inspections. Mechanics spend hours poring over the structure looking for cracks, loose rivets, signs of corrosion, or any deformation. Missing a small crack in a critical longeron or bulkhead could have devastating consequences down the line. Let's talk about a hidden workhorse in a helicopter: the transmission or main gearbox. It converts high-speed, low-torque power from the engine into low-speed, high-torque power for the main rotor blades. It also drives the tail rotor and other accessories. If this critical link fails, you're in trouble. The transmission is packed with gears, bearings, and shafts. It's a masterpiece of engineering, but a potential point of failure. Heat and lack of lubrication are its biggest enemies. Oil lubricates and cools the components. An oil leak or pump failure can cause temperatures to skyrocket. Bearings can seize, gears can wear, and metal can fail. Many helicopters have chip detectors to catch metallic particles. A chip light in the cockpit is a serious warning. It indicates maintenance is needed before a minor issue becomes major. Ignoring it is like ignoring a rattling sound in your car's engine. The loads on helicopter transmissions are immense and fluctuating. Tracking hours and overhauling parts at set intervals is crucial. So, we've taken a pretty unflinching look at some of the ways these incredible flying machines can run into serious trouble. From rotors to engines, controls to the very airframe and transmission, it's clear that helicopter flight is a demanding business, relying on a symphony of complex parts all doing their job perfectly. When that symphony hits a sour note due to a mechanical failure, the silence that follows can be deafening. It's a stark reminder of the respect these machines and the forces they command deserve. Now, the point of all this isn't to make you nervous next time you hear that familiar whop 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 overhead. Quite the opposite. It's to highlight the absolutely critical role of diligent, regular maintenance and thorough inspections. Every pre-flight check a pilot does, every hour a mechanic spends with a wrench and an inspection mirror, every scheduled overhaul. These are the invisible shields that stand between a normal flight and a potential disaster. It's the hard, often unglamorous work done on the ground that ensures safety in the air. These aren't just best practices, they are lifelines.